In this video, we're going to continue our discussion on solving logarithmic equations. So let's take a look at this particular example then. But now notice this equation has two logs on the left-hand side. The two previous examples only had one log expression. Can I simplify from two logs down to one? And the answer to that question is yes, because the bases are the same and it's separated by addition, I can multiply. So that would be log x times x is x squared, x times 21 is 21x. Now remember, if you don't see a base for the log, we assume it's 10. So as an exponential, that is 10 squared equal to x squared plus 21x. So we know 10 squared is 100. Equals x squared plus 21x. Subtract 100. I can factor this. Factors of negative 100 that add up to be 21. That's positive 25 and negative 4. Set each factor that contains a variable equal to 0. Now, let's check x equal to 4. So that is log 4 plus log of 25 equals 2. Well, when you combine the logs, you multiply, so 4 times 25 is 100. And we do know 10 squared does equal 100. So x equal to 4 checks. Now, let's check x equal to negative 25. So now we can take a look. Log of negative 25 does not exist. And this does not exist either. So x equal to negative 25 is not a solution. Remember, the domain for logarithmic expressions has to be greater than 0. Okay, so let's go to the next page then. So again, I have two logs on the left-hand side. Can I condense those two logs down into one? And the answer to that is yes, because the log bases are the same and it's separated by subtraction, I can divide them. So now I can write this out as an exponential equation. So 3 squared is 9. Okay. Multiply both sides by x minus 2. Don't forget I got to distribute. Okay. Subtract the x. Add 18. And then divide by 8. Okay. So that's 15/8. Now keep in mind, that's going to be 1 7/8. If you plug in 1 7/8 to either one of these logs, it's going to be log base 3 of a negative number. Again, that does not work. The domain of logs has to be greater than 0. So what does that tell me? I have a no solution here. So always make sure you plug in your answers to make sure that they make sense. So in this case, I have a positive number that does not work. Okay, so let's take a look at the next example then. So I got log base 5 of x squared is equal to log base 5 of 9. Because the logs are exactly the same, I can set what's inside the logs equal to each other. Take the square root of both sides. I have two solutions, x equals plus or minus 3. Okay. Again, very easy to plug in. 3 squared is 9, and then negative 3 in parentheses squared is equal to 9 also. So now I want to solve this log equation. Now, similar to what we did a couple of examples back, because it's addition, I can combine them into one log by multiplying. So x times x is x squared, x times negative 1 is negative x. Both of them have the same base, which is 10. Again, they're common logs. Okay. I can now write what's inside the logs equal to each other. So subtract the 12. Now I can factor this. There are factors of negative 12 that add up to be negative 1. That is negative 4 and positive 3. Okay. You can set each factor equal to 0, so we know x equal to 4 and x equal to negative 3. So again, negative 3 is not going to work because log of negative 3 doesn't exist. Okay. But let's check x equal to 4. Remember, you can combine logs here by multiplying. So we can tell very quickly that log 12 equals log 12. Okay, one other example I want to take a look at then. Again, I can combine these two logs into one because the bases are the same and it's separated by subtraction, which means I can divide them. Because the bases are the same, I can set what's inside the logs equal to each other. Okay. So I can multiply both sides by 1 minus 2x. Again, don't forget to distribute. Okay. So I'm going to add the 6x, subtract the 5, and divide by 5. Now, again, you look at this and see a negative number, probably not a solution, but we want to check to verify. Okay, so 5 minus a negative 2/5. That's 27/5. Okay. If we do negative 2 times negative 2/5, that's 4/5. 1 plus 4/5, that is 9/5. Okay. Again, the log bases are the same, but it's separated by subtraction. I can combine them for division. Okay. Let's do that work somewhere on the side. Let's do that down here. This divided by this is the same thing as this. Notice those divide out, and 27 divided by 9 is, 3. So in this particular case, a negative number is a solution. Okay? So just because I have a solution being negative, you cannot always conclude that it's not a solution. Just like from the couple of examples back, just because you have a positive answer does not necessarily mean it's going to be a solution to this equation.